Something is happening inside you right now that was decided a million years ago. Not by medicine, not by diet culture, not by anything you chose, by fire. Here is the question most people never think to ask. Your gut is dramatically shorter than a chimpanzee's relative to your body size. Your stomach is small, your colon is truncated, your small intestine is long, and your body extracts energy from cooked food at a rate that raw food simply cannot match. Why does any of that exist? The answer sits in a cave in South Africa, and it changes how you understand every meal you have ever eaten. About 1 million years ago, in what is now the Northern Cape of South Africa, a group of Homo erectus were doing something no animal had done with reliable consistency before them. They were cooking. We know this because in 2012, an international research team led by scientists from Boston University and the University of Toronto published findings in the Proceedings of the National Academy of Sciences confirming something extraordinary. Inside the sediment layers of Wonderwerk Cave, they found microscopic traces of burned bone and ashed plant material dated to approximately 1 million years ago. The analysis pushed back our confirmed evidence for controlled fire use by 300,000 years. The stone tools found in those same layers are Acheulean, the signature tools of Homo erectus. These were not accidental wildfires blowing debris into a cave. The burned material showed no signs of wind or water transport. This was deliberate heat applied to food inside a shelter. And right there, in that cave, the trajectory of your gut changed direction permanently. Here is what that fire actually did to your biology, and the science here is specific, well documented, and still running inside you right now. Your gut is built around a trade-off. On one side of that trade-off sits your gut. On the other side sits your brain. Both are metabolically expensive. Your gut consumes roughly 14 to 15 watts of energy per kilogram of tissue, while your brain burns energy at approximately 9 times the rate of the body average. Running both at full scale, at an ape's body weight, is not biologically viable. In 1995, anthropologists Leslie Aiello and Peter Wheeler published what became known as the expensive tissue hypothesis. Their central finding was direct. The smaller relative gut size in humans almost completely compensates for the metabolic cost of our larger brains. The gut shrank so the brain could grow. We have a basal metabolic rate comparable to other primates of similar body mass, despite a brain that is roughly 3 times larger than a chimpanzee's. That equation only balances if something else gets smaller. That something was your gut. Research from the Smithsonian's Human Origins program confirms that Homo erectus evolved a narrower ribcage and pelvis, shorter large intestines, and longer small intestines compared to earlier hominids. In apes, the colon makes up roughly 50% of total gut volume. In your body right now, it accounts for only around 20%. Your small intestine, the section devoted to rapid digestion and nutrient absorption, dominates instead. This is not a trivial anatomical difference. A large colon is built for slow fermentation of bulky plant fiber. It supports a different microbial community. It extracts energy slowly. It requires a different diet. The fact that your body moved away from that design corresponds precisely with the shift to cooking. Your gut did not shrink randomly. It shrank because it no longer needed to do the same work. Fire was doing part of the job instead. Consider what cooking actually does to food at a cellular level. When you apply heat to a starch in the presence of moisture, a process called gelatinization occurs. The starch granules swell, crystalline structures break down, and the chains of glucose become accessible to your digestive enzymes. Research published by Harvard human evolutionary biologist Richard Wrangham and supported by subsequent work from Rachel Carmody at Harvard's Department of Human Evolutionary Biology shows that the ileal digestibility of cooked starch reaches at least 95% in foods like potatoes and wheat. Raw potato starch, by comparison, has an ileal digestibility of around 51%. What that means for your body is concrete. You extract nearly twice the energy from a cooked potato compared to a raw one. Carmody's research also showed that cooking reduces the energetic cost of digestion itself. You spend less energy processing the food while getting more out of it. That is a compounding advantage. More calories in, fewer calories burned getting them. Every meal your ancestor ate by firelight was more efficient than anything eaten raw. This matters because it explains the brain. The human brain burns around 20% of your body's resting energy, despite comprising only about 2% of your body weight. That is an extraordinary metabolic demand. Without a consistent, reliable, high-calorie food source, growing and maintaining a brain of that size is not possible. Cooking provided that source. This is also why the current standard calorie labeling system on food packaging is, according to the researchers, technically inaccurate. It does not differentiate between raw and cooked forms of the same food. Your body does. The shift to cooking did not just change the size of your gut. Research suggests it changed who lives inside it. Your gut microbiome is not a static feature of your body. It responds to diet. And when the dominant food inputs shift from raw fibrous plant material to cooked, gelatinized starches and heat-processed animal protein, the community of microorganisms shifts with it. A 2024 paper in Microbiology and Molecular Biology Reviews by Rowland and colleagues, examining gut microbiota in the context of human evolution, makes the case that the microbial community inhabiting your colon was likely reshaped as Homo diet changed with the emergence of fire and cooking. The human gut today has less than 60% of the colon mass expected for a primate of our body weight, compared to carnivores of similar mass. That reduction in volume changed the microbial habitat available. Research into the AMY1 gene tells one part of this story particularly well. The AMY1 gene encodes salivary amylase, the enzyme in your saliva that begins breaking down starch the moment food enters your mouth. In chimpanzees, AMY1 copy number is consistently low. In humans, it varies from 2 to 24 copies, with an average of around 6 to 8. Studies from the University of Sydney and Cornell University have confirmed that people with higher AMY1 copy numbers have a different gut microbiome profile, with higher abundance of resistant starch-degrading bacteria and elevated short-chain fatty acid production. Researchers believe this amplification in copy number is a signal of recent selection driven by a shift to higher starch intake. Cooking made starch accessible. Your genome responded by producing more of the enzyme to process it, and your gut microbiome calibrated itself to that new substrate. This is not a trivial genomic detail. It tells you that your salivary chemistry, your gut bacteria, and the architecture of your digestive tract all carry evidence of the same prehistoric transition. The fire did not just cook the food, it rebuilt the system that processes it. At this point, I want to stay with you for the rest of this. What your body does right now when you eat, when you digest, when your saliva hits a mouthful of starch, is a direct consequence of what happened in that cave. If you are not on the channel yet, the next video we have coming builds on exactly what you are learning right now. But first, stay here. Prehistoric narrative. You are inside the cave. The fire has been burning for 2 hours. The air is heavy with wood smoke and the smell of charred bone. Outside, the savanna at dusk is going quiet. The light is dropping fast. The group has been moving since before sunrise, 12 to 15 people. Today they found a large animal carcass, competed for it, butchered what they could carry, and walked back here before the dark brought other predators. This is not unusual. This is every few days. One of the group places root vegetables directly into the coals. Not because they read about it, not because anyone told them it was nutritionally beneficial, because they have learned over time that cooked food does not require the hours of chewing that raw food demands. Cooked food fills the body faster. After a cooked meal, the group can rest sooner. They can sleep deeper. Inside their guts, something has already been underway for thousands of generations. The digestion of cooked starch begins in the mouth. Salivary amylase breaks the gelatinized chains almost immediately. The food reaches the small intestine in a form that is easier to process. Nutrients are absorbed earlier in the digestive tract, rather than being fermented slowly downstream in the colon. The body extracts more. The brain is fed. That child eating the cooked tuber tonight will grow a brain 22% larger in volume than the early Australopithecines who did not have reliable fire, not because of a single night, because of thousands of nights, because of every group that kept the fire going. The fire is not a tool for that group. It is the center of the camp. It is where the group gathers. It is where information moves. It is where the food gets soft enough to eat quickly. It is the most important thing they have. Now step back out of the cave and into your own kitchen. The principle is identical. The fire is different. The scale is different. The gut running the digestion is the same. Modern application. Here is what the research on cooking and digestion tells us about the gut you are running today. Your digestive system is structured around cooked food. It has been for at least 1 million years, and likely longer. Your small intestine is proportionally elongated to rapidly absorb nutrients from pre-processed food. Your colon is proportionally shortened compared to apes because it no longer needs to be the primary site of energy extraction through fiber fermentation. The implications cut in more than one direction. On one side, cooking unlocked the brain you are using to process this sentence. Without that caloric efficiency, a brain of this metabolic demand does not get built or sustained. You owe the cognitive capacity you have to the shift that Homo erectus made at a fire in South Africa 1 million years ago. On the other side, research suggests your gut is now adapted to expect cooked, processed food. When you eat large volumes of raw, fiber-dense material, your digestive architecture handles it less efficiently than a gorilla's would. Your colon cannot ferment it at the same scale. Your gut wall is built for speed, not slow bulk processing. This is why modern nutritional science, according to researchers including Rachel Carmody at Harvard, argues that standard food calorie labels are technically inaccurate. They do not account for preparation method. Cooked and raw forms of the same food deliver different amounts of usable energy. Your body knows this. The labels do not. This video is for educational purposes only. The information presented here is based on peer-reviewed research in evolutionary biology and nutrition science and is not intended as medical or dietary advice. Here is where it all closes. 1 million years ago, a group of Homo erectus in a cave in what is now South Africa held a fire long enough to cook their food. We have the ash. We have the burned bone. We have the stone tools. The event is documented, dated, confirmed. What happened next took tens of thousands of generations. A gut that was built for slow raw food processing began to change its proportions. The colon got shorter. The small intestine got longer. The colon's share of gut volume dropped from 50% toward 20%. The AMY1 gene began to amplify. The microbiome shifted toward organisms that thrive on cooked starch. Your gut is not the gut of a primate adapted to raw leaves and fruit. It is the gut of a species that outsourced part of its digestion to fire. Every time you cook a meal, you are completing a process that was started in a South African cave 1 million years ago. The next time you eat something cooked, your salivary amylase is going to begin the job before the food even reaches your stomach. Your shortened gut will extract nutrients efficiently and quickly. Your brain will be fueled in a way that raw food, at the quantities your ancestors could have consumed, could not sustain. You are the biological product of a fire that was lit before your species had language. There is a question that follows naturally from everything you have just learned. If cooking restructured your gut by making food more digestible, what did the specific foods your ancestors cooked do to the other systems of your body? What did that first fire do to your gut bacteria specifically at the species level? The research on that question is more recent, and the answer involves your immune system in ways most people have never heard explained. That is what comes next. If understanding the biology you are actually running is the kind of knowledge you want to keep building, staying on this channel is the most direct way to do it.